Look at the lead code problem, binary tree level order traversal. So this problem is a common phone interview question for the big tech companies. So in this problem, you'll be given the root of a binary tree and you need to perform a level order traversal of it. So here's an example where given this binary tree, the output should be a list of lists. So in this way, the first index will have all the elements at the top of the tree. So in this case, it's only 3. The next would be the children of 3, so 9 and 20. And then the next will be the children of 9 and 20, which is 15 and 7. So in this way, we are printing all of the nodes at each level of the tree. So to implement that, we'll need to basically create a queue to traverse all of the nodes until we reach all at the end of the binary tree. So yeah, for solving it, let's first create the data structure to store the result. So the output would be stored as a list of lists. So we'll just make it array list. So one of the cases they have given is that the number of trees could be in the range 0 to 2000. So an empty input can also be valid. But if that happens, we'll just return back an empty list. Now we'll just create a queue data structure for storing the nodes. And in the beginning, we'll just add the root to the queue. So now we are going to just traverse all of the nodes inside of the binary tree. And also to do that, first thing we need to do is just store what are the different values at each level of the tree. So for that, we'll create a list. And also, since we're now going to store all the elements level by level, we need to keep track of how many nodes were there at each level. So for that, before we get started processing it, we'll keep a variable to store the size of the queue. So then we'll just traverse down the queue and start adding the elements to it. So here, as you can see, we are now traversing down the binary tree. So every time we remove an element from the queue, we make sure we're adding the children to the end of the queue. So yeah, we keep doing that until all of the values in that particular level have been added. So yeah, at the end, we'll just add it to the result. So yeah, let's try running the solution. Oh, node.var. So yeah, the time complexity will be O of n, where n is the number of nodes in the binary tree. The space complexity will be also O of n, since we are just creating a queue data structure to traverse down the binary tree.